my first question is, how many people have a calculator that allows them to type log base 2 of 6 in? Log base 2 of 6. Apparently I have a calculator that sometimes allows me to do it if I'm patient. So, to type in log base 2 of 6, if your calculator lets you, if you have the fraction button on your calculator where you go alpha y equals, which is alpha f1, you can also have done alpha f2, and then there's the log base one. So if you hit all the f1, f2, f3, f4 menus can all be gotten by pushing the alpha button. And so if you have it, you can put it that way. It's also under the math functions, but it's hidden at the bottom, so you don't see it right away. If you have a scientific calculator, you're going to have to check. But most scientific calculators and older graphing calculators don't have the log base 2 in there, so you can't just type in, wrong buttons. Can't just type it in 2.5849. But if you have a regular graphing calculator, you could say, let x equal log base 2 of 6. And you have the following when you change it to exponential form. The base is 2, the exponent is x, and the answer is 6. So then you could take either Desmos or a graphing calculator and you could put this part into y1 and this part into y2 and see what happens. So I go back to my graph, I go to my y equals. And in 1, I can put 2 to the exponent of x into y1, and I can put 6 into y2. And I can look at the graphs and see if they intersect. They do, so I can go second, trace, number 5, find out where they intersect, put enter on the first curve, enter on the second curve, enter when you guess, and I get the same answer, 2.585, from my graphing calculator. But now the question is, what if I don't have the log base, and what if I don't have a graphing calculator? What if I just have a scientific calculator, which is what I'm going to be allowed on my exam? What do I do then? Well, if we started with 2 to the x equals 6, and the only log buttons you have on your calculator are the log button and the natural log button, you would be allowed to do the following. I can, because log is a function, just like square rooting, just like squaring. If you square root one side, you have to square root the other side. So if I log one side, I have to log the other side. And we learned a new log law that says, hey, if you have an exponent inside a logarithm, what can you do with that exponent? You could bring it out in front. Well, if I bring it out in front, then my equation looks like this. And I have x times log 2 equals log 6. How hard would it be to get x by itself? What's the opposite of multiplying by something? Dividing. So I divide both sides by log of 2. And now I have a fraction, log of 6 divided by log of 2. I'm going to go to my calculator, right? And I'm saying, well, I don't have the base button. What happens if I do log of 6 divided by log of 2? I get the exact same answer. So now if you only have a scientific calculator, this would allow you to do that. What other log button do we have on our calculator? Natural log. So let's say we did the exact same thing, but instead of taking the log of both sides, I took the natural log of both sides. That's allowed because what you do to one side, you do to the other. And just because it's a natural log doesn't change any rules. That x would come out in front. So that's a log law. So then I would have x natural log of 2 equals natural log of 6. And dividing both sides gives me natural log of 6 divided by natural log of 2. And I'm curious, if I go back to my calculator, does this come out with the same answer? Natural log of 6 divided by natural log of 2? It does. And like I said, once you get to AP Calculus, you almost exclusively use natural logs. I talk to students who are taking engineering and physics and calculus in university. They're like, I haven't touched the log button forever. We only use natural logs. On a purely practical sense, if you use a natural log, you can write it that much faster because it's only 2 letters. And log is 3 letters long, saving you valuable time. Now this idea of being able to take something like log 2 of 6 and be able to change it to either log 6 over log 2 or be able to change it to natural log of 6 over natural log of 2 is called the change of base theorem, which is we showed this already, but changing the base of a logarithm is on the top of page 402. It's a formula up on the wall, but it's the only formula not on your formula sheet. Some interesting things about the formula, and I've color-coded it here. So if you have the left side, if you have any logarithm of any base b of x, you can change it. And what's fascinating about this formula is, do you see that the orange letter A only appears on one side, on the new side, on the right-hand side of our formula? Which means if I had, let's go, yeah, blue. If I had log base 2 of 6, which is what we were dealing with before, I can change it to log of, I'm going to just put an orange circle for now, log of anything of 6 divided by log of anything of 2. I can put any number in there that I want, because the A is only on the right-hand side, as long as I put the same number in there. So most common is 10, or E. If it's 10, you use your log button. If it's E, you use your natural log button, and they'll get you the same answer. But you could, I mean, if I wanted to be, right, I could put anything in there, log base 1, 2, 3, 4, 5, 6. This might hurt my computer's head, or my calculators, and do that again. 1, 2, 3, 4, 5, 6 of 2. It should give me the same answer as log 6 of 2 as all of these other ones. Oh, it was pretty quick. I'm impressed. Good job, Kelsey. Now, why would you ever want to change it to 1, 2, 3, 4, 5, 6? Then you really have to write a lot of extra numbers. But this is the idea of the change of base theorem. So sometimes you'll see multiple choice questions will do a couple of examples here. They would say, multiple choice, log 3 of 7 is equal to what? And they might have this as an option. It's equal to log 7 over log 3. It's equal to log base e of 7 over log base e of 3, which is the same as natural log of 7 over natural log of 3. And sometimes you will get questions that make you use the change of base theorem backwards. So you have a dividing, and you could change it from the right-hand side of the change of base to the left-hand side. So this says combine as a single logarithm. The first problem I see here, right, these ones are just logs, so there'd be like invisible tens there. And the other one is a log base 3. They're not the same base. So if logs aren't the same base, you cannot use logarithms or log laws to work with them. We want to get a single logarithm. But I notice here with this fraction that I really have the right-hand side of this formula, and I could change it to the left-hand side by just writing it as log base 3 of 7. And now everything has the same base. So what's my log law for adding? It's multiplying. And I get a single logarithm. All right, so let's look at example 1. Approximate to the nearest thousand, so of course this would be a calculator question. If you had to do it first in your head without a calculator, can you see that the answer for this one should be somewhere between 2 and 3? And if you didn't have the base 5, or you forget where to find it, because that happens sometimes, because it's not easy to find on your calculator, well, I would probably just change this one with the change of base and say log 5 of 50 is the same as log 50 divided by log 5. That's easy enough to quickly type into my calculator. And we said our answer should be between 2 and 3, and there it is, 2.431. I rounded to 3 decimal places automatically, because on your exam, 3 decimal places is the minimum. And then I reread my question, and it says to the nearest 1,000. Is that to the nearest 1,000? Right? These are your tens, these are your hundreds, these are your thousands. Same thing in B. Maybe I use natural law. First of all, mental math-wise, you know that 8 to the power of 1 is 8. So this has to be 8 to the power of 0 point something. That's good to have in your mental math, because sometimes in the change of base, you're doing it quick and you might put the wrong number on the top and the wrong number on the bottom. So it's nice to know ahead of time with an estimate that I know this should be somewhere between 0 and 1. .862.
I got 1.
You got 1 for this one?
Yeah.
And if you look at your numbers. Yeah. So again, there would be a place where if we're just doing our calculations and just pushing enter without thinking, what happened is she accidentally typed in 6 twice, which your brain is, if you're thinking about the next thing, typing things into your calculator takes almost no brain work whatsoever. It's pretty mundane. It's pretty pretty easy to do, and it's pretty easy to make a mistake and not notice it if you're not thinking at all about it. And you get an answer. If that answer, that's why that little mental math check beforehand is like, wait a minute, this doesn't seem right. I don't think 8 to the power of 1 is 6. And so then you check your work or try it again.
Does it matter if you use log for that one?
No, if you just change a base doesn't matter if you have log or natural log. So I'm mixing it up to help you see that, right? You could, like I said, you could do log of 1, 2, 3, 4, 5, 6. 6 divided by log of 1, 2, 3, 4, 5, 6 of 8. But if you can do that on your calculator, you may as well just type in log 8 of 6 on your calculator to begin with. Mainly we learn the change of base because on scientific calculators and on most calculators, they just had logs and natural logs. It's just in the last, I would say, 5 to 10 years that calculators that students can buy have started to add the log base to make it even easier. Okay, questions you can circle for this one are 3, 4,